Welcome back, dear students. This is the lecture series of aerial photogrammetry. Now we are going to start with the second lecture of what are the steps to be followed in aerial photogrammetry. Very first thing is the planning and taking the photographs. So how these are to be planned and how the photographs are to be taken, in which direction it to be moved. We are going to see in next of the slides. Then after capturing the photographs, how the photographs they are processed. So what is the negative plane, what is the positive image plane, we are going to see. The third one is measuring the photographs and reducing the measurements to produce the results. In this third step, we identify different objects and we will measure the distance in the photographs. In order to measure the photographs, we need to understand what is the scale for these photographs, and any object, if it is in vertically, such like a tower or any building, how the height can be identified or determined using the same objects after identifying on the photographs. In aerial photo interpretation, basically there are two classifications. One is called as the visual interpretation, and the second one is the digital image interpretation. As far as your syllabus is concerned, we are not going to study the digital image interpretation. Now in visual interpretation, there are different basic elements. The first one is the shape. Here we, from the photographs, try to identify the objects based on the what are the different elements. So you can see shape, size, the pattern, shadow, tone, texture, and the location. In the first shape, there are different shapes of the objects that could be in a rectangular, or it could be a circular, linear, or curvilinear. So here the diagram, this is the picture taken as a aerial photograph. So you can see here the objects which are in curvilinear, but some of the objects could be a rectangular, circular. It can be easily identified. Just like for example, there is a football ground. So this is in rectangular form, but there are some sports stadiums which are in the circular form, just like a cricket stadium. So it can be identified. The same can be identified using the size, how the different objects can be compared. So for example, uh, there are many more buildings adjacent to each other. So we want to identify or compare with respect to how big and how small the buildings are. The third one is your pattern. In this pattern, basically we call it as a regular and irregular. Now in this image, you can see here, in this image, any vegetation, if it is well planned, that means whether it is, we have put this vegetation under cultivation with a uniform spread, and there are some vegetation which are spreading very haphazard manner. So you can see in this case, the vegetation which is spread very haphazard manner, and this one, you can see this portion which is spreaded or put under cultivation in a very systematic way. The next one is shadow. In this shadow, you can see in this image, uh, there is a, so see the shadow which is on this right hand side. Now how, depending upon how widely it is spread, that will decide what could be the height of the building. These are the simple the techniques. uh, Using the elements, the object height can be identified. Now next one is the tone, which indicates the color changing from a very light color to very dark color. So in this image you can see here, the dark, that means there is no absence, or there is no presence of anything. Definitely there does exist something, but that indicates also. So for example, a water body. So the only black color doesn't mean that there is no nothing is there. Similarly, you can see a very bright color that indicates some object here. Now coming to the next is the texture. The texture indicates how the surface is smooth or very rough surface. So in this diagram you can see this particular position where the vegetation is also there, but the surface is very rough. If you take see from the top, it will be not a smooth surface, whereas in this case you can see there is the water body which is giving a very uniform of a level. So therefore, depending upon the uniform or non-uniformity of the different objects, that will give you surface rough or smooth surface. The last one is the location. Location indicates whether the object is lying at the mountainous region or on plain surface like this. Already we have discussed about what is the aerial photograph. There are three different uh, types of is where vertical, the tilted and oblique. The this one, the area covered again is the small. So this is the vision. It is not always preferable to go for very oblique. As far as possible, this should be avoided. Now coming to the next, the same aerial photographs, we can say the um, this one is called the focal length. This one is called the image plane, and this one is called the again image plane, but this is called the positive and this one is called the negative image plane. So therefore this was I was telling you, this much portion is called the field of view, FOV in very short. So the more is the this distance f. Okay, see this one and this one. So you can see in this all these cases this f is called the focal length. As the focal length increases decreases, this will become more. So it is very inversely proportional, the focal length and the field of view, they are in inversely proportional. So if it is less than 40 degrees, we call it the narrow angle photographs. When between the 70 to 90, so normal, then above 90, 110, and above 100 it's a super wide angle. So it is always preferred to have the normal or standard angle photograph. Portion only this much portion that we are considering. Okay, so what is this point? This is the point is called as the your perspective center or exposure station, and this is your negative plane, right? Now if we try to divide into four 2 points, that means one along this and this along this, that will consider 4 parts, and the point center points, these are called on negative plane as the fiducial mark. So the point of this point is called as the fiducial center. You should understand this, and this is your flight direction. Now after having this, you can see there is a one point called the principal point. Now what is the principal point? If suppose the air flight is moving and it is capturing the photographs, there are no errors. There are no error that occur, but it really doesn't exist. So there are some errors, random errors that do exist. Now this point will not be matched with this point. So you can see there is some kind of the distortion, and this distortion, if happens, we call it this is the location of principal point. Okay. Now you will see that all the points will be passing through this one, and a line which is also passing through this one. This has to be truly vertical, that we have already seen, but some due to random errors, the point will be dislocated, and this point, in order to identify differently, we call it the principal point, and this will also pass through the principal point. Now after having understood this, see the same diagram here. Now how the image on positive image plane, the points will be appearing. Now uh, this point, from this one point, this is from the principal point up to the your perspective center, this is called as the focal length. So try to understand, the focal length is not a distance from this point to this point. So wherever you have to identify where is your principal point up to the this point. Now in the positive image plane, let us say this is your x-axis and this is your y-axis. Now if I try to produce from passing through this your exposure center, and on this your positive image plane, that will be appearing here. So you can see that this is the actually inverted image. That means what we can see here, it will be appearing on this side, opposite side. So this will be your the principal point on the positive image plane. Now if you draw a line or point line passing through this one, this and this is the same point passing through this vertical, and now what is this? This point is same as a fiducial center of this your positive image. That means again you are dividing this into four parts. The center which is formed, this is very much similar to the fiducial center point of the negative plane here, this one and this one. Okay, now if I try to draw this one point passing through this and this one, this is nothing but your gravity line, or we can say your truly vertical axis. Having understood this, we want to know what could be the scale of vertical photographs. Okay, now you understood this. This is here you are the perspective center, or you can say the exposure center, and here about is your negative image plane, and this one is called your positive plane, where actually after developing we get the photographs. Now from this O here, if you draw a line up to this plane, so this is your focal length f, and let us say there is a datum, could be anything, it could be mean sea level or any standard platform. So on this datum plane we choose any point A0 on the ground, sorry, on the datum. So if you try to draw a ray from this A0, and it will be passing through this your exposure point, so where this A0 will appear on your positive plane, here somewhere here. Okay, so similarly if I say K0 is the point vertically pass, if you start draw here from this O point and up to this your K0, so that point will be appearing as K on your photograph. Now if you say the point K0, this one, and A0, so this will call it the distance on the ground or on datum, that will be very parallel to this K A small A0 on your photograph. So therefore you want to know what is the scale of this of photograph, that will be the ratio of photo distance and the ground distance. So you can see very much, this is one triangle, okay, and this one is the another triangle. There are two triangles, so these two triangles are similar, therefore this horizontal distance and this horizontal is very similar to this vertical distance and this vertical distance. So this is, what is this vertical distance? This vertical distance is nothing but height, h. So what is the h? H is called as the flying height, which is measured from the datum to the exposure center. So the scale is equal to Ka0 and Ka0. Now you can see from the similar triangles what I was telling you, that is the Ka0 and Ka0. This can also be expressed as, this is the OK, this small k, and small O2, k zeros. Okay, so this is OK and OK0, right? So that will be OK is nothing but your focal length f, and this OK is your capital H. So from this also you can say the scale of photographs can also be expressed not only the in case of the distance but also in case of the height. So what is the height? F is a vertical distance, focal length, and H. So if you want to determine, most of the times scale of the photographs can be calculated without known distance of, if suppose this is the horizontal distance, this is not known to us. So the scale can be calculated if you are knowing which is the fixed distance as f, and what is the height above which height you are flying your aircraft. So taking the ratio of this, you can calculate what is the scale of your photographs, and from this the distance between any two objects can be calculated. That is the distance on the photographs can easily be. Now let us say somewhat changes I am going to do here. What you can see here is the datum, and apart from this there one I can draw a ground which is at some elevation above the datum, some vertical height or elevation I can show. So let us say any object, so ground could be like this, so this is your actually the A point on the ground. Now if you say the height of this or elevation, so if I say this is the 0 RL and this is some different RL, let us say 50 meters, so this will give HA is the height or elevation above the datum. Okay, so what is the 50 RL? 50 meters RL is nothing but the elevation of that point A on the ground. The same point you can say here. Now if you want to show where will be A point on the ground, so this will be your A point, sorry, small a on the photographs. So this is K0 A0 and this is your this point, this is the from K to A is nothing but very equivalent to on the photographs. Now photo distance and the ground distance, that will give you the scale. One more thing, uh, this is the above the ground, what is the height? So if you say, always you have to consider h is your flying height, which will be always measured with respect to the datum. So if you want to know with respect to the any ground point, because there are so many number of the points and all the points will have different elevations. So for any point if you want to calculate what is the elevation above ground, so that will be h minus ha. Okay, again looking to that, where is using this from similar triangles, what is the scale of photographs? S is equal to KA. So you can say this is the KA divided by capital KA. Now we are not going to apply K0 or A0 because these two, this datum and this ground surface, both are parallel. This one and this one, both are parallel. So whether you can take as a K0 or a K0 A0 or KA, so that is coming out to be same. So therefore it is, instead of K0 A0 I have written as a KA. So that will be again very, this ratio is a vertical as a F, and now here it will be not H but H minus A. Okay, so because we are knowing where the ground point is exactly, so from this the scale of vertical photographs can be calculated F upon H minus H. Simply you can, if you know what is the elevation of any point, this is actually HA. So and usually you are also knowing at what altitude you are flying the aircraft, and the F distance is the focal length, usually the manufacturer that will give the value of the photograph, sorry, of the camera. Same can be extended. Now there are two different objects, different points. Let us say this is your datum. Now let us say the one point A, this is another ground point B, which are on the either side of this. Now this is your the vertical axis. Now from this again you want to know what is these vertical photographs. Here the two different objects, the A and B, they are not at the same level. So first of all you have to determine what is the vertical height. So you know that h is always with respect to the datum up to the your focal point, sorry, exposure point. So therefore for a point the height here is h minus ha, and here is the another point B, so whose height is the h minus hb. So if you want to know, see for the a point, the scale for the photograph A is equal to that we already determined, and same scale if you want to determine for the B point. Okay, so that can be expressed like this. Okay, so from anything, either HA or HB, if one of them is known, you can unknown point another can be calculated. So basically the scales we usually express in three different forms. One is called the datum scale, then another is called the point scale, and the third one is the average scale. What is the datum scale? Usually datum scale is the mean sea level to be taken. We express datum scale as the SD, which is always the ratio of your focal length and your the flying height. Now the second one is the point scale. Point scale we express as the S suffix P. So this point scale for any particular point if we consider, this can be considered, but you know that there are many number of the points, so the point scale uh, is not same for all the points. So as the point height changes, so we will get the different scale for the different points. And the third one is the average scale. Average scale is, that means even though there are a difference in the elevation of different points, so if you want to show any photographs that we want to uh, express in one uniform scale, and that uniform scale we call it the average. So average indicates all the points, even though they are at different altitudes, different elevations, we express them on the same elevation. So that's a uniform elevation. But note it down, this is not that give your actual picture, but for time being we are considering this, and it will help you to work out different the elevations. Now the one more important is the relief displacement. I was talking you in the contents of today's lecture that if you want to determine the distance, vertical height, not distance but vertical height, any tower or any building, so from the photograph whether it is possible to interpret the height of any building. Yes, so for this you need to understand what is the meaning of relief distance. Now let us say there are 2 points. One is here, we call it the A point, and another point is B here. Now they are at different elevation. Now you can see here there is the datum. It is tried to show in 3D form. So this is your the positive image plane, and this is your, now for this you have to assume that your principal point and the center of the fiducial edges, they are the same point. That means there are no any random errors. The principal point and center of fiducial coinciding at one point. Otherwise it would be impossible to derive the mathematical equation. Now if you try to, okay, this is your exposure point, and just draw a line passing through. Now what is this? Before that, B point. So this B point, if you draw a vertical here, and this point on the plane, on the datum plane, so this is your B0 point. Similarly, if I draw this is point, and this will, that indicates one plane itself. So this is the A0, and this A0 is at the same level of your B0 point. And if I extend this upwards, this is nothing but my A point. So therefore, if you say this is my HA, what is the HA? The elevation above datum for the A point. Similarly, HB is my elevation for B point above the datum. So HA and HB are different elevations above the datum. Now from this, if I say draw a ray which is passing through your exposure point, and it will give the A points here on the positive image plane. Similarly, if I say this A0 point, and if I try to draw this from the exposure point from here, it will give your A0 points here. Similarly for B point, you get for this B point, B0 capital B and is a small b. So this is the point on the your photograph, and this B0 for your datum point. Okay, this is a small B0. So corresponding points, all the 4 points we have drawn. Now you know this is the K point. This is your the principal point as well as your center of your fiducial edges. So from this, if I join from this, definitely it will pass through this one. Definitely it will go through the both the points B and B0. Similarly, if I draw from this A, and this is okay, right? So you can see, if you want to know the elevation of, that is the HB here, this will be what is this distance. If you measure with the scale, that will corresponding distance you will get elevation point. Similarly, if you say this distance elevation, sorry, this elevation, that is the HA. So what is this? If you measure this on the scale AA0, that will correspondingly the elevation on the photographs. Okay, coming to this, you can say, for example, now we can say one specific object. Let us say there is a tower. Now what you want here, some elevation difference should be there. Instead of talking about a datum and any ground point, let us say we say this is the ground point whose elevation, let it be the datum here, but now we are considering here with respect to the ground. So your tower is resting on ground point. See, this is the height of point, or here point A0, sorry, and the top of your tower is A. So what it indicates? Height of the tower, HA. So HA here is your height of your tower. So time being, do not consider it is a with respect to datum. Okay, so time being considered it with respect to the ground point. Now from this, let us say from this A point, this is your positive image plane, this is your exposure point. Now this is the vertical. If you drawn through this principal point, somewhere on the ground it will be here. Okay, it will be somewhere here, and your datum point somewhere here. Okay, so you can say from K point to this your top of your A, and if you say the distance is the R. Similarly from this your datum to bottom of this, so this one HA and this distance is same. So therefore if I draw here from here to here distance, this will also coming out to be the R. Okay, same if you want to show here corresponding distances on your photographs. So try to, now if we convert into, this is just like a 3D, come into the 2D diagram. So you can see here, now see once again, this is your tower height, this is if a HA, and this height and this height is the same. Okay, so this is your datum, this distance is nothing but your R distance. So therefore from this point to this point up to A point, and this point and this point, they are the same distance. So if I say this distance is R, so this distance will also be equal to R itself. So from this exposure point. If I want to locate the point on positive photographs, here is your A0 and here is your A point. Okay. Now this distance is nothing but your HA, isn't it? Now if you know that from O point to your datum is your nothing but your flying height, so therefore from A point, the top of this, to the exposure point is nothing but your H minus HA, or you can simply H, you can write also. Now coming to this, you can say R. What is R? Is the distance. You know that K0 and A0, you can see here. Now if you take the similar triangle, what is the similar triangle? The focal length, this is one, you get this one. If you consider this triangle first, which triangle? This was triangle. So in this case, F is this vertical height from here and this vertical height from here to here. So ratio of these two taken equivalent to or equal to, what is this distance up to here? So what is this distance? Sorry, yeah, this is the R. This is your R, and this R is nothing but and is parallel to capital R. So therefore it is same as the ratio of this. So this ratio and this ratio is the same. So from this you can express R, small r, is equal to, take the cross multiplication, so this will give the expression. The same can be expressed for the entire flight height instead of h minus h. So for this you can write just like here, f upon h, focal length upon total flight height, is equal to, now instead of there, that will be r, instead of r there will be r0 divided by r. So r distance remains same whether it will be a0 or a point. So from this you can write what is the r0 is equal to rf. So just compare this to this, the expression, this one and this one. Okay, now we want to say what is the relief displacement d is equal to, what is d? R minus r0. Okay, that is very similar to what is your a0 and a. So we can say r minus r0 is nothing but what? This distance, and this distance is nothing but a minus a0, because a is more distance from your optical axis as a minus, so optical axis from this to the a point is more distance as compared to the a0. So therefore this is very similar to your a minus a0. Okay, so if you want to know this, that will simply take the subtraction of these two, and that also will give you what is the relief displacement. So that d is also known as the relief displacement, or if you want to say in case of this as what is the height of the tower.